Do for today is going to be maxMultiple. All right, so basically maxMultiple, we're given a divisor and a bound. We want to find the largest integer n such that n is divisible by divisor, n is less than or equal to bound, and n is greater than 0. And it's guaranteed that such a number exists. So, we're not going to get a bound value that's like 0. Right, because it's got to be something that's greater than 0, but also less than or equal to bound. So we're not going to have a bound value of 0. It's got to be at least 5, as it turns out, 5 to 100. Our divisor is going to be anything between 2 and 10. And yeah, basically we need to find the biggest. Now, okay, hold on a sec. Before we go any further, I'm realizing this is a lot of math words, if we're not familiar. So when we're talking about a divisor, we're talking about a number that divides into another number without a remainder. So it's basically the same as a factor, same thing as a factor. So, or at least in this context, it's the same as a factor. The point is, we could say, for example, the number 15 has divisors 3 and 5. Just, as a quick example. So, well, actually, hey, speaking of examples, we got one right here. If our divisor is 3 and our bound is 10, then basically the maxMultiple we're going to get is 9. So we want to look at the divisors of 3, and we're going to say, okay, so what are the divisors? Not the divisors of 3, the multiples of 3. So in other words, numbers that have 3 as a divisor. So what numbers have 3 as a divisor? Well, 3. That would be the first one we can think of. After that one, we can just add another 3 onto this, right? 3 times 2, it would be 6. Okay, so we're still under the bound. It's still less than or equal to bound, so that's fine. Next one would be 9. 3 times 3, that's 9. Okay, great. Is that under the bound? Yeah, it is. So we could keep it going. We'd say, all right, let's try 12. Oh, no, too far. No good. So then we end it there. Okay, cool. So let's do that. We'll basically run through it just like that. So we'll say let multiple be assigned the value of divisor. And while multiple is less than or equal to bound, we're going to say multiple times equals divisor. Get another one of those in there. And at the end here, we're going to return multiple. That's going to be it. Oh, what happened here? Oh, I know. We multiplied. When we were doing 3, 6, 9, 12, we're not multiplying by 3 each time. We were adding 3 each time. So I should be doing it plus equals. My mistake. Okay, and now it's still not right because look at this. We're going above the bound. We're going 1 too far. Subtract 2 from that, we're fine. Take 10 off of this, we're fine. And take 7 off of this, and we're exactly right. So we need to return basically multiple minus divisor. Okay. Hopefully that's going to work. Yes, and it does. Okay, does it pass all the hidden tests? Let's find out. It does. Cool. Hey, we're making great progress today. This feels good. So let's close that up. Now, I want to touch this up a little bit because I have to say, there's something about the way we're doing this that kind of bugs me a little bit, I guess. It's just the fact that we're kind of intentionally going overboard and then just going back 1. Instead of just doing minus divisor, why don't we take that minus divisor, put it up here. So that way we don't have to subtract it afterwards. Or equivalently, as you might remember, for a math equation or even inequality, whatever you add to one side, you can add to the other side, and the equation or inequality will remain balanced. So in this case, I want to add divisor to both sides. So multiple plus divisor is less than or equal to bound minus divisor plus divisor. Well, minus divisor plus divisor, that's the same as 0. So this should work just as well. And it kind of reveals maybe a different way of thinking about it, which is kind of cool, because we're basically saying, well, if we were to add another one on, would it still be less than or equal to the bound? Oh, it wouldn't be? Okay, we better not add it on then. And otherwise, if it would be, we say, yeah, well, hey, add it on. Go for it, right? So there we go. We get multiple, and it's what we want, right? Yeah. It passed all the hidden tests. It's what we want. Okay, great. So let's sort of archive this one. We'll say this is maxMultiple 1. And I want to do it a little bit differently this time. So if you think about it, like, again, this is a lot like multiplication, right? We're just bringing it up one bit at a time. We're basically multiplying our divisor by, well, what are we multiplying it by? We're multiplying it by basically the amount of times that it's going to fit into bound. So kind of like bound divided by divisor, or math off floor of bound divided by divisor. So could we do that? Return math off floor of bound divided by divisor. What is that going to give us, first of all? Well, this gives us 3. This is saying 3 fits in 3 times into 10. 2 fits into 7, also 3 times. 10 fits in 5 times into 50. Fits perfectly, actually. 7, how many times did that fit into 100? Well, it turns out 14 times. And notice 7 times 14 is 98. 10 times 5 is 50. 2 times 3 is 6. And 3 times 3 is 9. So if we multiply this by divisor, it should be good, right? And yeah, turns out we're good. But I want to point something else out. I mean, after we submit this thing here, this looks eerily familiar. I mean, I'm looking at this and I almost kind of recall seeing something like this recently. We're doing a math.floor of one number divided by another number and then multiplying it by that same denominator. Well, that's kind of exactly what we did over here. That's exactly the same thing. Math.floor of m divided by n times n. And actually, if you think about it, it turns out this is exactly the same problem. This is exactly the same problem as maxMultiple. The only thing different about this is the story that goes along with it. You know, this one has more of a narrative approach. The other one is exactly the same problem, but just using math words. And I'm actually kind of curious, because I see that this one has been solved 33,140 times. If we go over to the other one, it's been solved 27,647 times. That's like 6,000, almost 6,000 fewer submissions here, or 5,500 approximately. So that's pretty significant. Now, maybe it's because there was one in between and maybe that posed some difficulty. Yeah, and I guess it did. But still, it's a decent enough drop-off that makes me think that, you know, it might have something to do with the math language here, you know. A lot of people are less familiar or less comfortable with like really math style notation, but it's kind of interesting that you can have the same problem sort of dressed up different ways. You know what else is interesting? The example they give is the same in both cases. You know, in the other one, m was 10, n was 3. The answer was 9. It's the same thing. This is the same problem. So here, because it's the same problem, let's even just, let's get one other method here. I want it to sort of reflect the other one. So let's say maxMultiple 2, and then we'll basically do the other thing that we tried for that other one. So it's basically where we were taking the whole thing. We're taking bound, and then just subtracting from that bound mod divisor, just whatever we would get as our remainder, our leftover when we tried dividing this. And actually, hold on a sec. I've got to make this one not the right name and switch to that. Yeah, that still works. It's totally up to you which one you want to use. I'll call that 2, and yeah, we'll just do it like that. Okay, great. So, okay, that's kind of neat. You know, we have the same problem twice in here, but it's kind of funny. The first time I went through these, I actually did not pick up on that. So I guess it's, you know, well hidden enough that it's kind of sneaky. And I respect that. So, okay. I think that's going to be it for this one. Nice job. You're crushing this. Okay, great. So, that's all for today.